Hey there curious minds, welcome to Learn with Longman, and join us as we explore the transformative power of alcohol oxidation reactions. We will be uncovering the magic of these molecular changes and showing you how to turn this knowledge into some top results in your tests and exams. So, get those gloves on, hit that subscribe button and let's go. Carbon is a pretty unique element, and its valency of 4 allows for a gazillion potential organic reactions, which would have us here until the end of time. Yeah, we're going to skip eternity and dive into the ones that'll save your senior school sanity. Here we look at primary alcohol oxidation, but stay tuned for more videos on secondary and tertiary alcohols, esterification, and ester hydrolysis. The first thing you need to know is that not all alcohols are created equal. And we need to know this because the type of alcohol is like the secret ingredient which totally changes the chemical reaction. Let's introduce them. The primary alcohols, they've got that OH group hanging with just one carbon buddy. Secondary alcohols, they're the social butterflies, bonding with 2 carbon pals. And tertiary alcohols, they're the life of the party, and the OH containing carbon is surrounded by 3 carbon besties. Now let's get into the nitty-gritty of primary alcohol oxidation. Imagine the primary alcohol as the starting point. When the reaction heats up and an appropriate oxidizing agent is added, the OH group takes on a new identity as an aldehyde. And if things keep going, it forms into an acid, a carboxylic acid. It's like a chemistry glow-up, transforming step by step to become something new, beautiful, and potentially quite tasty if you like almonds and citrus fruit. Let's practice writing redox chemical equations for these reactions. First, let's check out the oxidation half equation using ethanol as a starting point. Let's look at the formation of the aldehyde first. Write out the structural formula of the reactants, ethanol and ethanal. The next step is to balance by adding 2 hydrogens to match the hydrogens on each side. Finish off by adding 2 electrons so that the charge is neutral. Voila! Ethanol's redox makeover into ethanal is a wrap. Now, oxidation does not occur in a vacuum, and it needs an oxidizing agent to occur. The 2 most common in chemistry are permanganate and dichromate, and you will find their half equations on all good chemistry data books. So if we used permanganate as the oxidizing agent, the 2 half equations would need to be balanced for the number of electrons by multiplying the oxidation half equation by 5 and the permanganate half equation by 2. This gives you equal number of electrons so that you can combine your oxidation and reduction half equations into an overall redox equation. Take care in this step to simplify by removing terms which are on both sides, like the pesky extra hydrogen ions in this case. Wow, pretty and satisfying. We don't have to stop there though, and if we want to make vinegar out of this wine, then we can convert the ethanol into ethanoic acid. A carboxylic acid has more oxygens than an alcohol, so this time we must balance the oxygens with water on the reactant side. As a consequence, we also need to top up the hydrogen ions and electrons as products. If we had used potassium dichromate as the oxidizing agent, as shown here, then we will need to balance the electrons by multiplying the oxidation half equation by 3 and the reduction half equation by 2. Once again, we can combine them together and make an overall redox equation. Not to go on, but it's pretty important to know how the reaction conditions affect the product formed. If you want the aldehyde, then a chemist will control the temperature, keeping it low, control the time frame, keeping it short, and limit the amount of oxidizing agent. If a chemist wants the carboxylic acid, then the reaction can be done a little hotter, a little longer, and with excess oxidizing agent. We say a little hotter as the temperature can't exceed the boiling point of the aldehyde, as this will result in a loss of aldehyde and no product being collected. We can get around this by setting up a reaction flask with a condensation tube as shown here. Have I mentioned my Teachers Pay Teachers yet? Well, Learn with Longman is your ultimate source for top-notch educational resources. Check out the link in the video description and elevate your lessons with our engaging materials, such as this booklet, which contains everything you need on organic reactions. Let's have a go at one of these and test your skills on primary alcohols. In this starter question, you are asked to describe the redox reaction of methanol to methanoic acid and to provide observations. The question is worth 5 marks, so pause the video, take 5, and come back to compare your answer. Oh, you're back. Did you balance the oxidation half equation with water, hydrogen ions, and electrons? Write the correct reduction half equation. Remember that this should be found on your data sheets. Combine them, making sure you reduce water and hydrogen ions on each side. The observations should be that the permanganate decolorizes from purple to light pink, but this will often appear colourless. Here is another question from my Organic Reactions resource on Teachers Pay Teachers. I am only showing part A and B here. They are worth 5 marks, so take the time needed, pause the video, and come back for the answer. Okay, check out the marking guide below. Did you identify both an oxidizing agent and the sulfuric acid which is used to acidify it? Did you explain that short reaction times, low temperatures, and limited oxidizing agent will help you yield the aldehyde? If so, well done! You have listened and learned. Okay, thanks for your attention, and be on the lookout for more reaction videos to come. Like this video, subscribe, and check out Learn with Longman on Teachers Pay Teachers to elevate your teaching game and your learning.